So 2.2. Thoughts here. Okay, so like on number 2, we have some absolute value of something equals 12. But remember, if the absolute value of anything is 12, there's only certain numbers that do that. Like if I were to say, like forgetting about algebra, the absolute value of anything, if it equals 12, there's only 2 numbers that do that. Absolute value of 12 is 12. That's what that says, 12. And the absolute value of negative 12 is 12. So it's the only numbers that absolute value out to 12 are 12 and negative 12. I guess what we could conclude then is, so maybe that 2x plus, or whatever, minus 3 part that's inside the absolute value, this part, it must be 12 in the first place if it absolute values to 12. Or maybe it's negative 12, you know? And so we say that. We'll say either 2x minus 3 equals 12, or 2x minus 3 equals maybe negative 12. 12 minus, you know? And some people do that with like a plus or minus 12 on there as one equation. That's fine too. And then we'll just solve them both, you know, and figure out what in the world x we're talking about in either case. So if we had the 2x there, let's see here, plus 3 is 15. So 2 times something is 15. We're looking at, you know, whatever, 15 over 2, I guess. And so divide the 2 on both sides. You got yourselves 15 over 2, also known as 7.5 if you want to decimal it. And then similar issue on the other side, we're just doing our thing, you know. Minus 3, so plus 3, and then negative 12 plus 3 is going to be something else. That's negative 9. Dividing that thing by 2, then we have, well, negative 9 halves, or 4.5 negative. That's pretty much all we're looking at for that. Something weirder happens as the problems go on, they get worse looking. And so, like, here's number 5. We have, in my version of it, it's 4 minus 3, absolute value of all this mess equals 11, negative. So that's a little bit weird right off the bat. I mean, we'll fix it up. But if you ever see an absolute value equaling negative, that could instantly be a no solution. Here we have answers, so I guess it's not that. But like, because you don't have absolute value of anything and it equals negative something. That's not what absolute values do, you know. Anyway, let's see if we can clean this up. I suggest that maybe let's get rid of these things that are outside of the absolute value first, and then it'll be just the 3x minus 3 in the absolute value equals something. Hopefully it won't be negative anymore. This one's particularly weird. Okay, so don't put 4 minus 3 together because there's an order of operations issue with that. We're just going to solve this out by getting rid of the 4 from both sides first. And so then, let's see here, what's left here is negative 3 times all this equals something. And so let's figure that out. We still have the negative 3, and the absolute value mess equals, I'll put that in there. But what's negative 11, negative 4, negative 15? Look at this, perfection. And then that's a 3, that negative 3 there. It's not like we're minusing it. We're timesing it with this absolute value. So we're going to get rid of it by dividing it. So we'll divide both sides by negative 3. Wonderful. And now it's 3x minus 3 absolute valued equals whatever the heck that is. And that goes in there. Double negatives make a positive. So we're looking at like positive 5, I guess. And now it's just like the last problem. So then we'll just, I don't know if I'm going to finish it, but it'll essentially be either 3x minus 3 equals 5, or else the only other thing that absolute values out to being 5 is negative 5. So 3x minus 3 could be negative 5. And then we just solve them both. You know, you do the little plus 3 and stuff to both sides. Dot, 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 solve. That's my take on number 5. I can solve them with you, of course, more if we need to. And then, let's see here. Here's another, here. Okay, so there's a few like number 5, but then number 8, we start graphing these things. And so it says sketch a graph of f of x equals 2 absolute value x. And so depending on how you want to approach this, we could do it real fast, or else we could plot dots. But remember, if we go by what we know of transformations, absolute value of x starts out as just being a 1 over 1 slope, and then it goes over to the other direction as well. This is what absolute value x looks like. If I have times that by 2 on the outside of the function, then you might remember that timesing by 2 outside means it's going to get twice as tall. Twice as tall, or it grows twice as fast or something. That might be a better way to say it. But it grows twice as fast, or it's twice as tall everywhere. And so instead of this, we're going to say that it's like a 2/1 slope. It's like by the time you go over here, over to 1, it's not up 1, it's up twice as tall as 1, or basically up 2. By the time you go here, the y value of the old function was 2, so we're twice as tall as 2, which is 4. And so we have this 2/1 slope going on. And then we'll mirror that on the other side, and it's looking pretty good. So this is kind of what we're looking at there. There's other perspectives on this as well, because, this is essentially, it looks like an mx plus b type function. It's a straight line function that's just a 2x. And so this has a slope of 2/1, 1, 2/1, 1, 2/1, with the intercept being plus 0. And then you mirror it once you get to the left-hand side like we do with absolute values. Anyways, that's another take on it. Wanted to talk to you. Here's a weirder one, though. Okay, so number 9, they start getting funkier. And so let's remember what we do about our translations and, other transformations. So at the very onset of this all, we're starting at the 0, 0 mark for a normal absolute value function. And then we just kind of go up and out at a 1/1 slope and then reflect it over on the left like we were saying before. And it keeps on going. This one's going to be a little different from that. So remember how this goes. Plus 3 means up 3. And then an x minus 1, we're looking for what x do I need to plug in to make this back to like a 0, so that by the time I absolute value it, I'm actually absolute valuing a 0. And so new 0, we call it. New 0 is, what do we say, positive 1, I guess. And that's an x thing. We're talking you putting in a positive 1 for x to get it to be 0 on the inside by the time you do the function deal. And so let's see how that looks so far. So far, before we even deal with this whole whatever the half thing's about, we know that the start point is not in the middle anymore. It's not at the origin. Instead of 00, our start point is at new 0 is positive 1, and then it's up 3. So we're starting from here. And then you'd be like, if that was all she wrote, then we'd be doing the absolute value thing from there. But that's not all she wrote, because now we got to deal with this mess. And so 2 aspects of that are, it looks like, first off, it's a half. It's a 1/2 slope, so it won't be this slope. It'll be a 1/2 slope. So it's 1/2, going out kind of that direction, I guess. And then the same thing backwards, up 1 and then backwards 2. So it's this thing. It's not quite as steep as it was before. And then the only other thing to account for is the fact that it's a negative. And so since we're timesing by a negative on the outside of the function here, timesing a negative means we're going to upside down it. So not only is it going to be a 2/1 slope both ways, but it'll be upside down of this. So we're going to start from the old 1, 3, and we'll do an upside down of this function, if you will. We'll flip it. And so now we're like looking at this mess. So it's down 1/2 to the left. Boom, bam. Down 1/2 to the right. Bam, that way. And then we'll just kind of I'm going to embolden that so that we know that that's the one that Adam actually landed on, because I drew so much other mess in here. Looking good. That's what I'm seeing. This is something that's over 1 to the right, up 3, and then it's times by a half slope, but it's upside down. So something like that. Here's what the computer said the answer was. I don't know. Mine looks better.